So the day before yesterday, I've got a special bowl that I take in my car for travelling with my breakfast. So a cereal bowl full of milk, muesli, yogurt, fruit salad, still sitting in the driveway. Upturned the bloody thing all down the centre console, all over the parking brake, the gear stick. And so I've got, milk pulled up in my coin jar and all that sort of thing. Christ, you know how you've got that thing where you've just made a spillage and you've got to do something real urgently? But what can you do? What can you do? This urgency wasn't going to help anything. So I was still sitting in my driveway. In the end, I just drove to work and left it how it was. Coincidentally, I have an ant problem in my car. It doesn't matter where I park, I get these bloody ants that come in and eat anything in the car. I don't know where they come from. I guess I've obviously got a nest in my car somewhere. So, okay, cool, the ants can take care of the cereal problem. And of course, the first day, they were right into it, ants all over the place. Thought, great, this is going to clean it up. But of course, after a while, they gave up. I don't know, they got sick of muesli or whatever, I'm not sure. So what I'm thinking now is maybe I should get some sugar water and maybe spray it over the area and see if that will sort of reinvigorate them and get them to get the rest of the crap off. I don't know. I'm stuck. And completely independent of that, I've actually got a car for sale if anyone's interested. So welcome to our talk today. We're talking about disaster recovery in the clouds. Which button do I push? So, who are we? How's this thing work? Oh yeah, just turn it on. So we're from OneNet. We're a cloud computing provider based here in Auckland. You can see our motto from there. We're all about delivering the same quality of computing that you expect in a large firm and delivering that out to individual users. So we do services such as hosted desktop, hosted Microsoft solutions such as CRM, SharePoint, Exchange, infrastructure as a service, so hosted virtual machines with Hyper-V. Myself, my name's Tony Weston. I am the Chief Technology Officer and co-presenter today, Gareth Fletcher. He is our Senior Solutions Architect. We've got this Twitter back channel thing, so you can actually do some sort of tweet if you've got a question during the presentation, and I certainly won't be looking at it, but Gareth might be. I don't know anything about Twitter. So the agenda today, we're going to talk a little bit about the risks. So we're going to look at the risks in traditional IT, how those risks change when you move to the cloud. Some of those risks go away, but some of them stay, and there's some new risks that get introduced. We're going to talk about business continuity. We're going to look at some of the new exciting enabling technology. Obviously, Microsoft stuff with the new release of R2, there's some exciting things happening. And we've got some really cool demos coming up later, which Gareth is going to show us, so please don't leave early. So some of the key takeaways for today. Who owns DR? We want to find out who should be owning DR. Who cares about it? Who should be involved in the DR process? What does DR look like? What should it look like? And what are the game changers? So maybe let's go through some definitions to start off with. We're talking about things like HA, high availability. So high availability, we're talking about how we can recover, carry on our services in spite of a failure. Disaster recovery is how we recover from those failures, how we do it in a timely fashion. Business continuity planning, so really that's, DR and HA are a subset of that, and that's really how a business maintains carrying on doing its business in spite of failures. Definition of cloud computing, so this is from the New Zealand Institute of IT Professionals, and really they're talking about delivering cloud solutions the same way you'd turn on a tap and get water. So cloud service models, if we look at traditional IT, we'll look up through the IT stack. All of those services are managed by the client. And as we look at some of the other things, infrastructure as a service, you can see the cloud provider starts to manage the infrastructure. They're really just delivering a virtual machine in this instance. If you look at platform as a service, the cloud provider's providing more and more of that stack, and software as a service. Once again, further up the tree. And the last one we've got there is business process as a service, where the cloud provider is actually maintaining all of the software all the way right up to the application. So let's look at some examples. Infrastructure as a service, obviously we've got our friends at Amazon, Windows Azure, Rackspace, platform as a service, Google App Engine, Force.com, Amazon Web. Software as a service, good friends at Office 365, which I'm sure you've heard about. Google Apps, Salesforce is a good one, Hosted Exchange, and business process as a service. There's probably a little bit of a grey area between business process as a service and software as a service sometimes. So MailChimp, I'm not sure if you've used MailChimp before, fantastic solution for sending out email newsletters basically. And what you'll find is that quite often business processes as service providers are actually running on top of other cloud providers. So I know that, for example, MailChimp in the past, don't think it does anymore, but it used to run on Amazon. So the National Institutes of Standards and Technology, they've got some broad capabilities that they define for a cloud provider. The sort of things you'd expect, on-demand, self-service. You can access your applications or cloud services from anywhere. You can scale up or scale down, and you can obviously have a look and see exactly what your usage is. The whole idea is that you're paying per usage. So why cloud? Certainly the question used to be, why would you consider cloud? But I think the question over the last year has changed to why would you not consider cloud? We've certainly seen with things like Microsoft Azure, sorry, I skipped a bit too fast there, Microsoft Azure, they have provided this great platform, so agile, flexible, driving the costs right down. So yeah, why cloud? Something that we obviously always focus on. Great flexibility, lower costs. You don't have to worry about IT. You can focus your IT resource on getting some value for your business. Less distractions. So I mean, consider this analogy in the olden days, a long time ago. People would never have considered someone else making their bread for them. They would have made their bread themselves. Why would you outsource it? You don't know that someone else is going to have the highest quality ingredients, the right cooking time, all of those sort of things. But obviously today we wouldn't consider making our own bread unless we were doing it for fun or had some sort of bizarre recipe that we couldn't get normally. Bakers and bakeries, they've got all the facilities to be able to provide bread at scale, quality. It's really a commodity item, and that is exactly what is happening with IT. It is becoming a commodity item. However, cloud computing is still IT. There's still disks spinning, there's still operating systems running, it's still running in a data center. It is not necessarily any new technology, it is really a business model innovation. It's using technology to deliver IT services in a different manner. But shit still happens, right? It's still IT. I'm sure all of you guys know that. So let's look at some of the risks. So if we think about traditional IT, technical knowledge. So in a traditional IT environment, let's call it legacy IT, in a traditional IT environment, there will be some technical knowledge, probably be quite broad but not very deep. A lack of agility. There might have to be some hardware purchases, infrastructure changes if you wanted to easily scale up and scale down. Unknown risk profile. I think this is a very important one. Very hard to quantify risk, particularly in traditional IT. And sometimes that makes it quite hard to make decisions about moving to the cloud as well. And there could be repeated issues, often small, maybe quite minor, but distracting from adding any value to the company from IT because you're always looking after the day-to-day.
I'm pleased to report another stellar week of accomplishments. I moved more than 800,000 bits of data to a disaster recovery backup facility.
Did you just take credit for copying a file to a disk?
It was my resume.
So that's a classic little Dilbert clip. I guess the point is it's showing that business doesn't necessarily know what's going on inside their IT environment, and the risk is quite unknown. So how do those risks change if we move to a cloud provider? What does it look like in the cloud? Okay, great. Suddenly we've got this agility, we've got this predictable cost, we've got this infinite resource, and also backed by technical excellence. But it doesn't necessarily mean that all our issues go away. Vendor lock-in. Now, cloud providers have been working really hard to make their solutions portable. As you heard from the keynote the day before yesterday, from Azure you can download your VHD and you can run that workload somewhere else. Data access, unfortunately, there's still the perception that getting access to your data is much easier if the server's sitting under your desk. Cookie cutter solution, obviously with cloud providers, they've got to provide a solution that caters for a whole number of different people, and so they can't have it customized for every particular organization. And in some regards, that is a bit of a risk for traditional IT. Loss of control, probably a perception more than anything, but as we saw from the cloud model, IT providers are providing more and more of that stack, less ability for a traditional IT to have any involvement. Data sovereignty, this one is very timely. You've probably seen in the news the NSA's copped a bit of flack for basically being able to hack and do anything they want, and obviously the GCSB in New Zealand is very timely. Outages, quite often feel helpless when your cloud provider has an outage. There's obviously nothing you can do about it, you have to rely on them. They've got the expertise to deal with it, but there is that feeling of helplessness. You've got to rely on your provider's reliability, that's an obvious one, and poor communication. Yeah, actually, this one, cloud providers are often bloody atrocious at giving feedback when there's an outage. They're obviously quite sensitive to publicity and sometimes a little bit slow to communicate what's going on. You've possibly seen this quote. Quite enjoy it, it's a good one. Why do we need backups? We can just get it from the NSA. Except that they won't give it to us. So the perception is that security is the biggest issue with cloud. But according to Gartner, the biggest issue is actually outages. So maybe let's look at some examples. These are some recent examples. The first one, a large hardware provider. This is a local example. I believe they were doing an upgrade on their SAN, which housed a number of their virtual machines. For whatever reason, there was some sort of failure, and they had to end up restoring everything from backup. This outage was sort of in the order of days, and as you can appreciate, they probably went through the decision process. How long do we keep trying to fix what we've got there before we start trying to restore from backup? And as you can imagine, on a SAN, there's a hell of a lot of data, and it just takes a long time to restore. Second example, a large software vendor who will remain nameless. They had some SSL certificates expire. The SSL certificates were basically part of their storage platform. The SSL certificates were right across all of their availability zones, across all of their regions. Once they expired, it basically shut out storage for their whole entire environment. So single point of failure, doesn't matter how much redundancy they had, everything went. That was back in February this year. Large bookseller that now is doing cloud. They had a developer who was making some changes to his development environment. Unfortunately, he was actually doing it live. He changed some settings to do with the load balancing environment, and unfortunately took out some data. The load balancing environment stopped working, had a bit of a snowball effect within their environment, and they had quite a considerable outage, something in the order of 14 or 15 hours. But the point is, even these guys who are all got the best expertise and the best systems, they still have outages, they still have problems, and I'm sure they've all learnt from them, and probably so have their clients as well. And interestingly enough, I would suspect that At least 2 of these examples are due to human error. Now, I don't have any stats on it, but my feeling is that human error is probably by far and away the biggest cause of outages. And within that group of human error, I would expect that probably the majority of that is when changes and upgrades are getting made. Which is a problem, because the competitive advantage of cloud providers is that they are always at the leading edge. They're providing the latest software, they're always scaling their environment, and obviously that introduces risks, because whenever they do that, they're making changes, and changes are typically done by humans, and it causes errors and outages. I was actually thinking when I watched the keynote the other day, listening to Sean, I wonder if there's some sort of way we can get some augmented reality to remove humans from the process. Might make a big difference. Now I'm going to hand over to my esteemed colleague Gareth, and he's going to probably tell you something a little bit more useful. Thanks, Gareth.
Thanks, Eddie. So we've examined the risks in traditional IT, what happens to those risks with cloud adoption, and how things can and will still go wrong in the clouds. We've seen, especially in smaller sized companies, without the necessary skills, they move some resources to the cloud, thinking that they're protected too, just because the cloud provider has some sort of recovery option. How can we remove surprises? How do we prevent the inevitable? How do we keep our clients, be they internal business units or end customers, happy? How do we clear the thunderstorms and see the sunrise over the turbulent sea of calamity we would otherwise face? First, let us remind ourselves, before we start throwing around ideas for high availability and particularly disaster recovery, especially ones we've seen so far at TechEd, however cool they are, we need to step back and sort of get a wider picture of where it fits into overall business continuity. Some random statistic that I'm just making up now again is that 63.2% of all businesses have no feasible continuity plan and no current future plans to have one. Often in businesses, especially in the small to medium enterprises, DR becomes something that IT needs to drive. But it has to be taken into context of overall business continuity. And this needs to be driven by the business owners and not by IT. Business needs for continuity must drive DR. Because there are so many other more risks that face businesses that IT simply aren't equipped to address. For example, terrorism, or supervillains, Dr. Evil or Skeletor, or time dilation, political unrest. Another problem is that a lot of people who are looking to implement a DR plan have what we call 100% syndrome. And that's they're obsessed with the number of nines a particular solution has. And this, of course, drives the cost of possible DR options up, where often non-IT related business recovery options are more realistic and cost-effective. Let us tell you a true story. There was this one company, and they had this super critical line of business application. And this application was used by their huge number of sales representatives. And these were to manage clients into sales orders. And it was determined that for every hour this application was unavailable, the company would lose tens of thousands of dollars of revenue. The sales agents teams were unable to work. With the importance understood, the company did everything right. They had backups of their backups, redundancy, bells and whistles. Anyway, despite this, one day, right on a Monday morning, their app crapped out. It was unavailable for several hours.
What happened?
Well, they had one of their biggest ever single days of sales.
How can that be?
Well, most of the sales agents had their client contact list printed out or in their email. They didn't know the products. They had to take orders from pen and paper. The sales agents talked to the customers from memory rather than from a screen. Often they engaged with the customers more than they had previously. They were unable to give customers a price and had to make the sale without even knowing the price. Now, we're not trying to say throw away your DR planning and leave it to the guys with the nicer cars. We just need to be mindful of where our DR strategy fits into the bigger picture when tasked with constructing one. Also, cloud computing doesn't and shouldn't impact business architecture, fundamental business continuity plans. Moving to the cloud doesn't necessarily change your DR requirements. It is just another technology enabler which can be leveraged as part of these plans. Because at the end of the day, you still have the same business processes, services, and apps running on these servers with disks and wiggle swip and things like that. You still need to balance cost and agility, legacy needs, and leverage the provider's various service offerings. How does cloud affect this? Business needs to own DR. It's not the cloud provider. The cloud provider is a fantastic enabler. It offers all sorts of tools to deliver on business DR, often at a price and agility that you'd never be able to achieve in-house. But the use of these tools needs to be driven by the business. Because we're at a point of change in time. Before, in the olden days, recovery was the goal. Now, disaster prevention and avoidance can be a realistic goal for many organizations. Also, this is becoming true for smaller and smaller organizations with the advent of cloud. With server virtualization, replication, consolidation, high bandwidth, the use of distributed data models, and things like that. Let's have a look at the traditional DR thinking. You'd have a single site failover. You consider the whole site to be critical. This would be extremely costly. You utilize things like SAN replication, having like-for-like hardware, or traditional backup with off-site restore, or your plans might be to get the firemen to pull out all your servers, blow the fires out, take them to your DR site. What about the new DR thinking? We can look at each system and consider a DR strategy for each. This typically allows for an easier entry into DR. Better DR is specific for each process and app, leveraging further high availability options, active-active site resiliency. This is ultimately more cost-effective and can be implemented in a piecemeal fashion over time. Changes can be dealt with individually. Upgrades can happen because you're not stuck on some technology you implemented 5 years ago. You could leverage platform as a service, infrastructure as a service. You could have exchange going on, Hyper-V replica. You can scale into the clouds. What are we trying to get at? Hybrid HA and DR is the new black. Decomposing business processes by workload and application into different levels of criticality and financial consideration allows better control of costs. You get more flexibility into choosing technologies that are best suited for your workload, of course. We can leverage different technologies, including cloud providers at all levels of the stack. You can leverage capabilities that may be specific to that technology, which drives our flexibility and agility up. In general, one size and one technology or one methodology isn't necessarily the best fit for all applications. Remember, granularity of business processes derives granularity of business continuity, and here we get granular options for our DR and our HA story. And this ultimately results in lower cost. With the recent advances in cloud and the smarter uses of technology, including leveraging Microsoft Cloud OS, the ability to be able to do this granular DR is now a reality for everyone, no matter how small. Let us go through a real-life example. Consider, you are the CIO at Contoso Limited and have been tasked with creating a revised DR plan. Presently, Contoso have a primary site in Auckland and a DR site in Wellington. And this is based on the old school traditional DR model, where you have a single site to take over all responsibility should your primary site go down, just based on SAN replication, and having complete like-for-like hardware. Of course, this is extremely expensive. And given recent time dilation incidents and run-ins with Skeletor, you have to head to review. You refer back to the company's business continuity plans, which have recently been revised with the support of upper management. These have a good high level of detail following a meaningful business impact analysis of the business units and relevant functions. The outcome of this analysis provides you with a detailed recovery point and recovery time objectives for your relevant services. Of course, that is, if there's a disaster at some point, the state to which you're restored from will be your recovery point, and the time it takes you to restore service will be your recovery time. The impact analysis found which services and functions were business critical. And we can classify how tolerant they are to outages by putting them in tiers. Looking at the critical ones, so we see a whole bunch of business functions. And if you just have a look at the critical ones, we see they have an order tracking, a warehouse management, and email. The order tracking is just based on Dynamics CRM with SQL 2014. The warehouse management is just some really old legacy 3-tier app, which is also for some reason running SQL 2014, which is very legacy, of course. And email is just regular Exchange 2013. Maybe. You investigate the DR options per service, evaluating the available technologies, determining which ones meet your particular requirements. Let's have a look. So we have a look at SQL. What can we do there? We decided to go with always-on availability groups. That meets our requirements pretty well. So we stick up some SQL servers, migrate the databases to it. And we're good to go. And I think some of those sessions have already been, so you haven't been, then tough luck. What about our web and front-end servers? We could do some stuff, but we decided to just put redundant servers in our second site. Or you could use the load balancer. What about our app server? I think this is running some really old OS, maybe Windows 2008 R2. What can we do? Let's use Hyper-V 2012 R2 replica. And we do just that. We stick it on Windows 2012 cluster. Have one in our second site, and we use Hyper-V replica. And there's some pretty cool features with 2012 R2 with Hyper-V replica as well. We can do extended replication to a third site, increase the frequency of our replication, and just generally awesome. And for Exchange, we just use regular Exchange 2013 site resiliency. Extend the DAG. And UCAS array in our second site. And we're good to go. This is where we were previously. So what have we done? We've leveraged these granular DR options to give us greater flexibility. What are some of the gotchas? Of course, it looks a lot more complicated, and you may run into more complexity with this scenario. Also, don't assume someone else has your ass because they don't. and plan for failure. You need to balance your workload over fault domains, availability zones, availability regions. Cloud providers, use things like trusted clouds or cloud brokers. They can leverage the resources of multiple clouds, multiple cloud providers. But leveraging the cloud for your DR plans comes with its own risks. How do you do it? We know that it provides us with infinite scalability, smart people and systems. But how do we architect our DR plans in such a way that we are not bitten by the unknowns, by the possible thunderstorms? We need DR unity. A unity between the provider and the business, with all parties together. The consuming business knows their business better than the cloud provider will be able to. They need to understand the SLAs for the services they're consuming and how they're derived. Things like non-negotiable SLAs, compound SLAs, and how they affect the SLAs that they're delivering to their own clients. They need to identify dependencies, contractual implications, and whatnot. They need to ensure they have an internal champion within the business. This person should become sort of the DR service owner and manage the DR architecture, plan, processes, and testing. And testing needs to occur frequently and thoroughly. Remember, avoid big assumptions. Easily falling into siloed architectures with this. Taking shortcuts. Don't forget the basics. There is no silver bullet for HA and DR, and often the best results need to incorporate a number of different technologies in a hybrid solution. There we go. Design for failure. Assume everything will fail. Avoid single points of failure. All parts of your application should be highly available. Load balancers, app servers, web services, databases. And now I will hand you over to Tony to take you through some of the enabling technology.
Hey, is anyone here running Hyper-V Replica in production?
No one.
Is that right? Interesting.
Is anyone running Hyper-V?
Yep, that guy way over in the corner there. I've got a prize for you. You ready? Soccer or rugby? Oh, that's all right, that's all right. Very flexible in the cloud, we can cater for all.
Good catch.
That's fine. Thanks, Gareth. So let's think about some of the exciting new technology that is going to help us have fantastic DR within the clouds. So with Windows 2012, Hyper-V, none of you are using it, but I can tell you it is fantastic. Really cost-effective solution, and it's only getting better with 2012 R2 release, which is coming out in the next couple of weeks. I don't know if you went to the keynote and you saw that it was announced that you can download it now from MSDN. Hopefully you can jump on there and download and have a go. I know I downloaded it straight away as soon as I saw you could enter some prize draw to show that you'd downloaded it. But really, our feeling is, since we're at a Microsoft conference, it really is a game changer. Really is a game changer. Let's go through some of the features. So if we think about Hyper-V in particular, guest clustering with VHDX. So if we wanted to have clustering before, we needed to have some iSCSI target or some virtual Ethernet, some virtual fiber adapters. But now we can actually have a shared VHDX file with clustered servers talking to it. Online VHDX resize, so you can actually resize the virtual machine hard disk while the virtual machine is running. Offline replica seeding, we can send a USB drive down to a remote location containing the VHD file to seed the replica. All of a sudden we can get over this bandwidth limitation. So tertiary replication, that's a critical one. With Hyper-V Replica introduced in 2012, you could replicate your virtual machines to one other host. Now you can replicate that to one other host plus an additional one. So typically in that sort of use case, you would have a replica running on site and you would have a replica off in a remote site. Online export, you can export your virtual machines while they're running, and there's been numerous live migration enhancements to really speed up the live migration process. So talking about the VHDX clustering. In this example, we've got a Hyper-V cloud running Windows 2012 R2, shared VHDX file. Now, that can actually be on SMB storage somewhere else on the network. We can have a couple of our virtual machine workloads clustered, talking to that same shared VHDX file. What's cool about it is it means that providers don't need to expose the storage architecture. It's simply a VHD file that the guests are talking to. It's really easy, and obviously you've got the ability to better run clustering, super simple. Hyper-V Recovery Manager, this is brand new, just been announced. It's actually an Azure service. Now what it does is actually orchestrates Hyper-V Replica to manage disasters. So you can have a couple of sites with Hyper-V talking to VMM, so System Center Virtual Machine Manager. They can be managed by Hyper-V Recovery Manager up in Azure. Now the great thing is you can actually manage failover completely, so it can inject network IP addresses, for example, when there's a failover. It can manage the failover based on particular workloads. You can group failover and have failover happen in certain order. It can also extend to not just a one-to-one, but one-to-many or many-to-one environment. And these sites can be outside of Azure, so they can be locally hosted with alternate cloud providers, and the Hyper-V Recovery Manager is actually managing the entire environment. Really, really exciting. It should actually be a bit of a game changer. Now, I'm going to go through a couple of demonstrations and actually talk about some of the stuff. So, Gareth, let's go for it.
Thanks, Tony. Let's have a look.
So, has anyone played with Hyper-V Replica? Rugby or soccer?
Soccer, thanks.
Ah, jeez. I've only got one soccer ball left. Good stuff. Hope that's your colour.
Yeah. Let's do a quick demo on guest clustering using VHDX. So let's run. Sweet. So we have a Hyper-V cluster here called Hyper-V Cluster 1 at our trusty Contoso company again. And we have two guest VMs running within that cluster. And what we can do is we can actually attach a VHDX file. It needs to be VHDX because for the SCSI persistent reservations, this actually sits on top of in the VHDX file header. We can attach this VHDX file into shared mode, which means that multiple guests can access it. So here it's got these two VHDX files, FS1 shared, FS shared quorum. And through the advanced features, we can enable virtual hard disk sharing. And if we jump into the guests, and have a look in Failover Cluster Manager, which isn't that. So we've created a cluster called Mike, of course. And we see the disk appear there. And now this just comes up as regular disks. So it doesn't. The guest VMs don't have to be running Windows Server 2012 R2. I think technically it needs 2012 to be officially supported, but there's no reason why you can't use older versions of Windows. So yeah, that's guest VHDX clustering. If we switch back. Let's have a look at a bit of a more exciting demo. Let's say we've got, back to that example with Contoso, let's say we've got dynamic CRM sitting on an always-on cluster, and we want to leverage Hyper-V Replica. So we have some SQL servers, 2 of them with synchronous replicas, and 1 of them is an asynchronous replica, sitting in our secondary site. Now these, this could be multiple cloud providers. It could be sitting on Azure or on-premise using the new site-to-site VPN feature. Or it could be, both on-premise. It doesn't really matter. The cloud doesn't really change this. And let's have a look. Nope. A bit of trouble. So here, back in our Hyper-V cluster, we have this server called CRM01. And we've got these 2 SQL VMs running SQL. And if we jump into SQL, we've created this always-on availability group. And we have this availability group listener called Charles. And because we're sitting in these 2 subnets, one on-premise and one on this other cloud provider, or between 2 cloud providers, zones, or whatever, we can assign it 2 IP addresses, 1 in each of the subnets. And then we're using this availability group listener in CRM. So CRM's a config database and the organization database for Contoso is sitting on this always-on availability group. And this availability group is spanning both subnets. What about the CRM server? Let's configure that up with Hyper-V Replica. So of course we specify the replica server. That's nothing new. That's nothing new. The frequency of replication, we can now change those. Previously, we only had 1 option. Now we got 3 options. That's a huge increase. 30 seconds, 5 minutes, or 15 minutes. What does that mean? That means we can put our replica on a server that's located far away, maybe with a really unstable internet or something. So we flick through this. And we're configuring the replica, and that should be seeding at the moment.
So in case you didn't get that, we've actually already just set up a replica between of a virtual machine between 2 Hyper-V hosts, and it's seeding. It's just so easy. It's bloody amazing.
So let's have a look.
Sorry, what's that?
Yeah, pretty sure.
Under R2.
R2 you can, yeah. So here's our CRM. So let's go ahead and start breaking stuff, because that's always fun, and we don't have much time because everyone's going to lunch soon. So our CRM is still seeding, but let's kill one of the SQL servers. Let's just turn it off. Well, of course, with that, SQL always on takes over. Where are we? And CRM stays up. Now let's imitate a whole site failure or a whole cloud provider failure by just shutting down those two Hyper-V hosts.
Except the replication hasn't finished.
Typical. %57%. I mean, were there any questions at the meantime?
Okay, I've got one more prize to give away, completely unrelated. Can you just ring my phone? If you guys can guess the ringtone, first one to guess it gets a prize. Just changed it.
I don't even have your number. %.
What's that? Who said that?
That was quick.
Too quick.
Should give him 2 prizes for that.
Soccer, rugby league, touch. I haven't got any left.
Fight the other guy. I don't think this is going to work.
You ready? Nice one.
Okay, 92%, it's almost done. What's the best way we can kill these two Hyper-V hosts?
You guys probably want to think about some interesting questions during question time because I've got one more ball left. When I say interesting, I mean ones that we can easily answer and make us look good.
Okay, so that replica's finished seeding. And we can see it now on the host that's located on our other site. So let's go ahead and kill both of those Hyper-V hosts. Let's just shut them down through the Blade console. There's one down. And let's kill the other one. So that could be, both the host die or the whole site dies, the cloud provider, and something happens that blows up. We're actually going to film ourselves burning servers, but logistically that was the problem. And so what have we got? We've only got our Hyper-V server sitting on our other site, and the replica, and our SQL asynchronous replica. So we can go ahead and turn this on. Hyper-V Recovery Manager will make this a lot easier.
So with Hyper-V Replica, you need to manually turn on the replica. Obviously, you want to find out, the extent of the disaster, for example. With Hyper-V Recovery Manager running in Azure, it can orchestrate that whole process and manage it for you. You can run scripts beforehand and after to make sure that it should be failing over.
And here we go, it's running. If we flick back to our stereo map. And of course, for always on, we need to spell that over too. Maybe not. Could have happened. Check if our Serum box is running yet. Come on. Can, yeah.
Yeah, so similar to what you can just do in native Hyper-V Replica, you can actually bring up the replica effectively off the network and make sure that if you've chosen to have some recovery points within that replica, make sure that they're all consistent and all that sort of thing without affecting your live production environment. And replication will carry on happening in the background even while you're running the test solution.
Latency, network latency for replication, how much of an issue is that in New Zealand, and especially if we're wanting to replicate to an overseas provider?
Yeah, that's a very good question. Once you're seeded, replication is pretty good, so there's a few recommendations. One is to make sure that you have your page file on a separate VHDX file, on a separate virtual file, and do not include that in replication. Obviously, it depends on how much your data is changing within the workload, but in R2, I know they've added some additional compression in the replication data stream. But there'll be some use cases where probably latency is going to be too much of a problem, but in most cases it's pretty effective. Yeah, and being asynchronous, it only really matters how far out of sync it's going to get. Yeah.
Should you have a separate network for replication traffic, separate to migration?
Yeah, good question. I think for Hyper-V Replica, Gareth, you can probably correct me if I'm wrong here, they've designed it in such a way that you can actually have your replica site somewhere else on the internet in an untrusted zone. Doesn't even need to be on the same domain, and the replica can happen over SSL, so it can happen straight over the normal internet, completely secure. So I would suggest that the design criteria is that no, you do not need a separate replica connection. I don't believe so.
Oh, well, my Hyper-V server is just frozen, so let's move on.
Yeah, There was a couple of good questions there, guys, by the way. Number 1. Oh, you've already got a ball. Oh, good. Number 2. Do you have a colour preference?
Good catches.
Catches when matches.
So what are we trying to say? Make sure you test. The business needs to own DR. And DR should involve all parties. They need to have an understanding of everything. Also, test regularly. A hybrid approach can be best. And test without assumptions.
And it doesn't mean shit unless you test, guys. You've got to test it, otherwise it doesn't mean anything.
Can we mention you have to test as well? I think we mentioned that.
Any more questions? Yeah. So recovery managers and Azure service.
That means that if that system goes down, you have to pull back to a manual process again.
So are you talking about if you had a Azure failure and a failure within your site at the same time?
Or anything that essentially takes Azure out, so you do not have access to recovery manager at all at that point.
Right.
For example.
Yeah. I'm not sure, but I assume it'll be status quo. So if Hyper-V Recovery Manager can't talk to your recovery sites, everything will... Not at this stage, no.
But Hyper-V Recovery Manager is supposed to be ultra highly available, so it shouldn't ever go down. There's like an agent that you plug into a virtual machine manager to talk to Hyper-V Recovery Manager just over HTTPS. So if you're a site, yeah, that's pretty much it.
That's a good scenario, but usually in DR, your whole site might be down. So your network's down.
That's fine. Your alternate site will have VMM as well, talking to Hyper-V Recovery Manager. Or if it doesn't, that's the first thing that you should get up and running, and then once that's talking to Hyper-V Recovery Manager, then it can orchestrate everything else. Or you can just do it manually.
I just want to understand the new Hyper-V features. Can you, say, have an app server OS instance which exists physically in more than one location?
No, that would be Hyper-V Replica, or if you actually had some sort of app level thing that you could do that with. Like with, say, Exchange, you can have your CAS server sitting on multiple sites and things. Yeah, thanks everyone.
Okay, thank you everyone. I think it's lunchtime.